Hello everyone. So today my topic is antenna and waveguides. Antenna and waveguides are critical components in communication system, particularly for transmitting and receiving electromagnetic wave at various frequencies, including radio, microwave, and satellite communication. So we will detail explanation of antenna and waveguides. They are their type and application and key characteristic. So first we talk about the interaction. So an antenna is a device used to transmit or receive electromagnetic wave in convert electro signal into electromagnetic wave for transmission and vice versa for reception. Antenna are essential in radio, television, radar, satellite communication, and wireless network. You can say antenna is a metallic conductor system capable of radiating and capture electromagnetic wave. Antenna are used to interface transmission line to free space to transmission line or board. In addition, a transmission line couple energy from transmitter or receiver to an antenna, which turn couple energy to the earth atmosphere and from the earth atmosphere to a transmission line. At the transmission and free space radio communication system, an antenna convert electrical energy travel along transmission line into electromagnetic wave that are emitted into space. At receiving end, an antenna convert electromagnetic wave in space into electrical energy on transmission line. Waveguides are structures that guide electromagnetic wave from one point to another, usually at microwave and higher frequency. Unlike antennas, which radiated energy into free space, waveguides confine and direct the wave, minimizing loss and interference. And in the other word, a waveguide is a special type of transmission line that consists of conducting metallic tube through which a high frequency electromagnetic energy is propagated. A waveguide is used efficiently in interconnect high frequency electromagnetic wave between antenna and transceiver. Okay, next is a type of antenna and waveguides. So there are many type of antenna and also the waveguides. Okay, so we will go through each type. The first one is dipole antenna. So dipole antenna, the structure is consists of two conductive element or rod connect to the transmission line, and it's used in the radio and television broadcasting, wireless communication, and as a reference antenna is in testing. So for the characteristic, the most basic type of antenna often used at frequency below 1 GHz. Its length is typical half wavelength of frequency. It is designed to transmit or receive. So the next is a monopole antenna. So monopole antenna is a single root like a conductor mount perpendicularly over ground plane, and it is commonly common use in mobile communication. Uh, for example, in the car and radio and broadcasting and GPS system. So the characteristic is similar to the dipole, but use the ground as the reflective surface, effectively doubling its length. So the next is Yagi-Uda antenna. So this type of antenna consists of a driven element like a dipole, a reflector, and one or more director. So it widely used in television reception, amateur radio, and point-to-point communication. And for the characteristic, highly rational with a focused beam, providing gain and providing a signal strength in desired direction. So the next is parabolic dish antenna. So this parabolic shape a reflector with a feed antenna at focal points, and it is used in satellite communication, radio, telescope, and radar system. And for a characteristic, extremely high gain and directivity suitable for long distance communication and high frequency application. And next is part or micro strip antenna. So a part or microstrip antenna is a type of antenna that consists of flat rectangular or circular part of a conductive metal mount on a dielectric substrate. It's widely used in various wireless communication applications due to its low profile and rest ease of integration with print circuit board. So this type of antenna, flat rectangular or circular metallic part mount on the dielectric substrate above ground plane. So it is used in the mobile phone, GPS device, and the other compact wireless device. And for the characteristic compact and easy integrate into the print circuit board with auto rate gain and directional property. So next is on antenna. So this type of antenna, a flare mental waveguide that form a horn shape, and it is used in microwave frequency range, including radar, satellite communication, and microwave link. And for the characteristic, provide a good gain and directivity with relatively broad bandwidth. So next is a loop antenna. So this type of antenna is a loop or coils of wire, sometimes multiple turn, and it is used in AM radio direction finding equipment and RFID system. And for the characteristic, sensitive to the magnetic component of electromagnetic waves, compact with directional property. So next is isotropic radiator antenna. So This type of antenna is a theoretical concept used in antenna theory. It represents an idealized antenna that radiate electromagnetic wave equally in all direction in three dimensional space, which no reference direction. It is often used as a reference standard compare the performance of a real antenna. So this type of antenna, in practice, there is no real antenna can be isopic radiator because all physical antenna have some directivity. However, the concept is crucial in antenna theory for comparing and designing a real-world antenna. So the next one is a Rubik antenna. So this type of antenna is a type of a directional antenna that is shaped like a robust or diamond. It consists of four long straight wire arranged in a diamond or rhombic shape. These antenna usually used for the high frequency transmission and reception, and it's known for simplicity, wide bandwidth, and ability to provide high gain over long distance. So it is used in point-to-point long-distance communication, often employed in fixed station for high-frequency communication. Sometimes it used in shortwave broadcasting. So next is dielectric root antenna. So this type of antenna is a type of antenna that used in dielectric material as a radiating element. The dielectric rod is typically cylindrical rod that guide and radiate electromagnetic waves. This type of antenna is often used in applications that require high directivity and efficiency, such as millimeter wave and microwave communication. So it is used in radar system, commonly found in millimeter wave communication system. Utilized in satellite and space communication, employed in experience set up for high frequency research. So the next is dielectric lamp antenna. So this type is a type of antenna that use dielectric lamp to focus or shape the electromagnetic wave radiated or received by the antenna. The lens is made from dielectric material such as plastic or glass, and then it typically positioned in front of a feed antenna, such as a horn or dipole, or control the direction and beam width of radiation. So it typically used in the radar system, used to focus radar beam for the better solution and range, and satellite communication, ideal for directing signal to and from satellite where precise beam control is essential. And microwave and millimeter wave system. commonly employed in systems that require high frequency, high gain antennas. In optical system, sometimes used in optical frequency where similar principle applies. So next is array antenna. Array antenna are complex system that use multiple individual antenna arranged in specific configuration to achieve enhanced performance compared to single element antenna. So this type of antenna, the application used in radar is for target tracking, surveillance, and navigation, and for satellite communication, for high gain and steerable antenna used in communication satellites. And in communication for base station antenna that provide coverage and capacity in cellular network, and in medical imaging in technique like MRI via array antenna help in imaging and diagnose procedure. So array antenna are highly versatile and can be tailored for various applications, providing enhanced performance and capability compared to traditional single element antenna. So, so next is we talk about type of waveguides. First is a rectangular waveguides. We talk about structure. A hollow metallic rectangular tube, and for the application it used in microwave communication, radar system, and in connecting component like antenna and transmitter. And for the characteristic support TE uh, transfer electric and TM transfer magnetic mode, with TE being the domain mode in most practical application. So next is circular waveguides. And for the structure, it's a hollow cylindrical tube, and it's used in high power micro application, satellite communication, and particular accelerator. And for the characteristics support multiple mode, including TE and TM mode, but it is less commonly used in then rectangular waveguide due to more complex mode pattern. So next is flexible waveguides. For the structure is flexible, usually corrugate metallic tube, and it used where the waveguide need to bend or adjust position, such as airborne radar system. For the characteristic offer flexibility with minimal signal loss through generally at a higher cost and with more attenuation than rigid waveguides. So the next is waveguides. So right waveguide, the structure rectangular waveguide with one right inside. So for the application used to widen the operation bandwidth and in high power application. And for the characteristic provide broader bandwidth and better impedance matching compared to standard rectangular waveguides. And the last one is coaxial waveguides. The structure is a central conductor surrounded by the insulate layer, uh, a metallic shield, and outer insulate jack. And it's used for low frequency microwave signal and in RF application. And it is allowed for the propagate of uh, TM transceiver electromagnetic mode, offering flexibility and erase out use in low frequency application. So here are the type of waveguides, and now we learn the key parameter of antenna and waveguides. So one is gain. Gain, a measure of how well antenna convert input power into radio wave in a specific direction, usually measured in decibel or dB. And for next is directivity. Directivity, the ability of antenna to focus energy in specific direction. And next is bandwidth. Bandwidth, the range of frequency over which the antenna operate effectively. And the next one is polarization, the orientation of electric field of the radiated wave, horizontal, vertical, or circular. And then last one is a radiation pattern, a graphical representation of the distribution of radiation intensity in space. So we come to the key parameter of the guide. So cut-off frequency, the lower frequency at which is a particular mode can propagate below its frequency. The wave is attenuated rather than transmitted. Most of propagate the specific field pattern within a waveguide. Common mode including TM and TEM. Attenuation, the loss of signal strength as a wave propagates through waveguide influenced by the material and frequency. And for the last one is power handling. The maximum power a waveguide can transmit without damage, important in high power application. So the next is antenna application and waveguides. So broadcasting use AM, FM radio and television broadcasting. And for the communication, mobile network, satellite communication, Wi-Fi and Bluetooth. And navigation used in a GPS system, and radar, military, weather forecasting, and air traffic control. And the last one is scientific research, radio, astronomy, and remote sensing. So, and for the application of waveguide, microwave communication. For microwave communication, use microwave link, radar system, and satellite communication. And for the high power RF transmission, waveguide are essential in transmitting high power RF signal in radar and particular accelerator. And for the instrumentation, waveguide are used in laboratory and measurement equipment for handling microwave signal. And for the last one, antenna feed system. Waveguide are often used in feed antenna, particularly in parabolic dish system. So now we come to the conclusion. So both antenna and waveguide are crucial component in the transmission and reception of electromagnetic wave. Antenna are responsible for radiating or capturing wave, while waveguide affectionately direct this wave from one location to another without significant loss. Their design, parameter, and application travel through the specific need of a communication system, whether it is for low frequency radio broadcast or high frequency satellite communication. So, thank you. That's all for the antenna and waveguides.